Examples from day 5. So this is when you have, it says using y-intercept and the slope. It means they're in slope-intercept form. And so this first one, let's go down a little bit. The first one is y equals x plus 7. And doesn't look like there's an m or a number in front of the x, a slope. But there is, it's just a 1. And if it doesn't show it, we just think of it as a 1. So then the two numbers we have here, 7 is your y-intercept. So on the y-axis, 3, 5, 6, 7. So that's where we start, and then we use the number for the x as a slope to find another point in whichever direction we want. So that's 1, but that is a fraction. We want a fraction when we're finding the slope. And so basically it means, this just means up 1, right 1. Because the top number is always up or down, bottom number is always left or right, and the positives and negatives just change direction. So if the top number is positive, it's up. If it's negative, it's down. The bottom number, you could have it as negative, it is left, and if it's positive, it's right. So up 1, right 1. And you can always keep on using the slope to find more points to make your line better. And this is actually the same as -1 over -1. If you change both signs, it's still the same slope, because the signs will cancel each other out and you'd simplify to this original one anyway. And the reason why that might be convenient is because down 1, left 1 may fit on our graph better, and it's the same line. So there's our line. In the next one, in the case where you have y equals 5, there is no x. So we should really think of this, or we could bend our minds a little and think of this as 0 times x plus 5. Because if this were simplified, we'd still have just y equals 5. But this at least allows us to realize, oh yeah, slope is 0. So if it's 0, it means 0 over 1. That's our slope. And we have the y-intercept of 5 still. So 5. And then if we didn't go up at all, or down at all, 0, and you went to the right one, then you'd have a point right there, and that's your line. It's just a horizontal line through the y-axis at 5. So in general, I mean, if you just have y equals 5 to graph that, it's just a horizontal line going through 5. If you have x equals 5, it's a vertical line going through the x-axis at 5. Those can be tricky, but that's it's a quick explanation of it. Here are a couple more examples that are part of this section that are somewhat relatable. If you have a function and you're asked to find the 0, it means you're asked to find where it crosses the x-axis. So what that means is, like, this is almost in slope-intercept form. It's not, but I mean, it's an f of x, but you could write it the same thing as slope-intercept form. So it'll be 1/2 x plus 6. And this is going to seem like a lot of work or extra work. It's not really. We would just plug in 0 for y. We want to find the x-intercept. And we could simplify this. To get x by itself, we're going to subtract 6 to both sides. Bam. And you get 1/2 times x. I'm a fan of, instead of dividing by 1/2, I like to multiply by the reciprocal, because that will also cancel out the fraction. And then I'm just multiplying by 2 of 1. So -12 is what's called a 0 of that function. And it also, if I wanted to graph it, that would just be you know, at -12, that's the point, and I could graph it using slope-intercept form because I have a slope right there, 1/2. So -12, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's just off the graph. That's fine. That would be my x-intercept. But if I wanted to graph it using slope-intercept form, I go up 6, 3, 4, 5, 6. That's right there. And then 1/2. So up 1, right 2. And if we followed this point here should line up. Down 1, left 2. 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 Right there. Cool. The next one's a little weirder. This is basically it's saying what's the 0, and your equation is y equals 19. Well, if you plugged in 0 for y, you have 0 equals 19. And that's simply not ever true. So this, what that means, if we have like a contradiction, 0 can't be equal to 19. So we don't have a 0. This does not have a 0. It does not cross the x-axis. And that should fit with what we just learned up here, in that if we have y equals 5, it's a horizontal line. Well, that doesn't cross the x-axis. This is a horizontal line too. At 19, it does not cross the x-axis. So it's just somewhere way up here on this graph. And then very briefly, I think we end up talking about this coming up, but as a preview, this is point slope form. Zoom out a little bit here. And it's very helpful because if in the case where you don't have the y-intercept, or maybe you have a slope, but then you just have some point, it would stand to reason that we should use point slope form. So this comes in. I mean, I enjoy using it because it's not too difficult of a formula to remember, I guess. But the only new thing here is this and this. That those represent a point. The y and the x are just regular. They have to be in the equation for it to be the equation of a line. Just like in standard form or in the previous ones we had a y and an x, and in slope-intercept form we had a y and an x. And so our point is x1, y1, and our slope is m. So if we had this example here, it is in point slope. It looks nice. Notice that this is a negative, or it's a subtract x1 and a subtract y1. So we basically take, like x1's right here in this position, and this is y1. We take the opposite signs of those when we pull it out of the equation, because it's supposed to be a subtraction, but it's a positive. So this is really, for the x part, it's -1. For the y part, we have it looks like a -3, but it's actually positive. We take it out and put a positive. Okay? So it's just always the opposite for those. That's one little hiccup that people can come across. The nice part is slope is exactly the same. It's just 2 sitting out front. So you have a point, and you would graph this similar to a slope-intercept problem. Plot our point that we have, -1 plus 3. That's the point that we know. And then use the slope, 2 over 1, to find another point. That's up to right 1, up to right 1, up to right 1, or down to left 1. And graph.